Hey guys, this is Mr. Grice for Algebra 2 Unit 4.1 4.6 review. Remember to factor each polynomial completely. Now, if you forgot the rules of factoring, we have this wonderful poster that Ms. Carranza made. If you don't have it, I would write it down, maybe pause the video and put it in your notes. Okay, let's move on. So, factor each polynomial completely. We have a trinomial. We always check to see is there a GCF, and there is not. So I would look for multiples or things that multiply to get to negative 24 and add to get to 5. Okay, so there are a lot of multiples of 24, or factors of 24, I'm sorry. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. So the only way to get to 5 is with 3 and 8. One of those numbers needs to be negative, and it's a negative 3. And it works in both situations. So that means I can split that middle term. So we have x squared minus 3x plus 8x minus 24. Okay, and then I can take the GCF out of the first group, which is an x. The x comes out front, and we're left with x minus 3. The GCF at the back is an 8, and it was a positive 8. And then when we divide that, we're left with x minus 3. So we match, so I know that x minus 3 and x plus 8 is my answer. Now, it does not matter if you write x minus 3, x plus 8, or x plus 8, x minus 3. So, remember, the first thing that we're always supposed to check for is a GCF. And when I'm looking at number 2, sorry, with a 3 in front of it, there's a GCF. 3 goes into all of those, so the 3 comes out front, and then we're left with w squared minus 8w plus 7. Now, I don't want to forget about my 3, so I'm going to bring it all the way down here into my final answer. I'm going to make it look like a 3, so I don't forget it. All right, so now that I've taken out the GCF, I'm looking for numbers that multiply to get to 7 and add to get to negative 8. Well, the only multiples of 7 are 1 and 7, so that works, but that doesn't work. But I have to make them both negative. It works, and a negative times a negative is a positive. So we have to split that middle term to get w squared minus 1w minus 7w plus 7. The first group I can take out a w. The w comes out front, and we're left with w minus 1. And in the back, I can take out a 7, but since my leading coefficient's negative, I need to make that negative. So then we get w minus 1. So 3 times w minus 1 times w minus 7. Final answer. All right, number 3. So remember, always check, is there a GCF? Yeah, 12 and 30, 6. And then they both have k's, and I look for the lowest exponent, and that's k squared. So I take out a 6 k squared, and then I'm left over with 2k minus 5. And that's all that I can do with this one. I'm not left with perfect squares. And that's the only thing I can do with the binomial. Speaking of perfect squares, look at number 4. Yeah, 121 and 81 are both perfect squares. Is there a GCF though? Check. Does 9 go into both of them? Nope. Okay, so since there's no perfect squares, or sorry, no GCF, I can go straight into perfect squares. The square root of 121 is 11, and it would be an 11n. One's a positive, one's a negative, and the square root of 81 is 9. So we have 11n plus 9 and 11n minus 9. And remember, the order of those do not matter. All right, number 5. GCF? No, no GCF. So I have to do 5 times 12, which is 60. So I'm looking for numbers that multiply to get to 60 and add to get to 16. Factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15. I know there are a lot. 5 and 12, and 6 and 10. Okay? So what combination gets us to 16? Yeah, 6 and 10. So 6 plus 10 works, and then 6 times 10 works. All right, so we got to split this bad boy up. I'm just going to move this over a little bit. So we get 5a squared plus 6a plus 10a plus 12. The GCF of the first group is just an a, and I'm left with 5a plus 6. The GCF of the back, yeah, it's just a 2, and that was a positive 2. 10 divided by 2 is 5, 12 divided by 2 is 6, and we match. So we got 5a plus 6 and a plus 2. So there we go. All done. Oh, gotta close those a's. There we go. All right, number 6. Is there a GCF? 3? No, because 3 doesn't go into 20. So we need to multiply. I'm looking for numbers that multiply to get to negative 180 and add to get to 24. So 180, we got 1 and 180, 2 and 90, 3 and 60. Does 4 go into it? Yeah, it does. 4 and 45, 5 and 36, 6 and 30. I know we're not done yet. 9 and 20, and then 10 and 18. Okay, so how do we get to 24? Yeah, 24 is going to be 6 and 30, and the 6 needs to be negative. All right, so we've done a couple of these now. You are on your own for the rest of this. I've got 9x squared minus 6x plus 30x minus 20. Okay, go ahead and pause the video and factor. Good luck. Okay, so the GCF out of the first group was a 3x, and on the back it was a positive 10, and then we get 3x minus 2, 3x plus 10. All right. Simplify the answer to determine the number and type of solutions of the quadratic equation. So in each one of these, we need to break it down and then figure out how many solutions it has. Now I need to break down the square root of 24, which breaks down to square root of 4 and the square root of 6, and the square root of 4 is 2. So we have x equals -8 plus or minus 2 square root 6, all divided by 2. And remember, we break this down to -8 over 2 plus or minus, and then 2 square root 6 divided by 2. And when we reduce that, we get -4 plus or minus square root 6. So -4 plus or minus the square root of 6. Now, how many solutions is that? Well, it's definitely not imaginary, so I can cross that out. Now, is there one answer or two? Well, remember, it's plus or minus, so that means that there are 2 possible solutions there. All right, number 8. Same thing, we got to break down that square root. The first thing that I see is that it's negative, so I got to take out an I. And then 32 breaks up into square root of 16 and the square root of 2. The square root of 16 is 4, so I have 4i root 2. So we have 6 plus or minus 4i root 2, all divided by 4. Okay? So we have to do 6 over 4 plus or minus, and then 4i root 2 divided by 4. After you reduce that, I'm just going to come over here. 6 over 4 is really 3 over 2 plus or minus, and then it's just going to be plus or minus I square root 2. Now, you should know right away that the I stands for imaginary. So there are 2 imaginary solutions. Number 9. What is square root of 0? The square root of 0 is just 0, so that kind of cancels out. And all I'm left with is -2 divided by 2, which is -1. And if -1 is my answer, that means that there is only one real solution. Okay. We're going to go ahead and stop the video right now, and backside will be on video number 2. So this is Mr. Grice signing off for Algebra 2, Unit 4.1, 4.6 review video number 1. Thanks for watching.